Okay, I think it's recording. Okay. Anyway, so yeah, let's talk about imaginary numbers. So an imaginary number, we call it I, and I is defined as root negative one. So throughout middle school, throughout the beginning of high school, you probably totally can't square root negative numbers. You could, you just put I. So for example, if you have like root negative 4, you don't have to write this down, but if you have root negative 4, I know root 4 is 2, obviously, right? Root negative 4, we say is 2I. We say it's 2I because it's like root negative 1 times root 4. And if you think about it, root 4 is 2, but root negative 1 is actually I. And then there's a pattern. If you square I, you square the radical, it becomes negative 1. If you do I cubed becomes I squared times I, which is negative 1 times I, or negative I. If you do I4 is I squared times I squared, which of course is negative 1 times negative 1, which of course is positive 1, and so forth. So that's all that's happening, right? So root negative 48. Let's talk about that one. So I'm gonna break it down like this, right? There's no harm in doing that. You could totally break up radicals this way, right? Because radicals are like exponents. For example, if you have like 2 times 3 squared, you could break it up like this, right? It's the same thing. It's still gonna be 36. Doesn't matter, right? And a radical is an exponent. What exponent specifically square roots? It's raised to what power? You guys remember? Square roots raised to, like, if you have root x, that's x to what power? Good, x to the 1/2, exactly. So it's just an exponent, right? Now, the 48, can I break the 48 down even more into something that's easy to work with? Like, is there a factor of 48 that's a perfect square? Well, what are perfect squares? Like 1, 4, 9, not 12. Oh, yes, 4 and 12, you're saying that. Let's go even higher. What about if I did 16 and 3, right? I could break it down like that. And what are you going to get? You're going to get 4I root 3. So that's what I'm looking for to simplify it. Excuse me. Excuse me again. So let's look at example 2 now. Negative 12 times, now root negative 36. Well, what's root 36? So you have a negative, so you make it 6i. There you go. And then you multiply it together and you get negative 72i. And again, you don't see imaginary numbers in calculus, so it's kind of funny we cover this again, but what the heck, we're going to do it. But the stuff we do after 7.1 for sure. And by the way, this packet is for the whole unit. I'm not sure when our next test will be. Let me pull it up again. You might be happy with me. It might be during. Okay, it's after Spirit Week. Okay, good. I think you guys be really upset if it's during Spirit Week. So it's after Spirit Week. So we're going to spend some time on this for sure. All right, let's come back here again. Also, another thing about this packet too, I accidentally put one of the homework assignments in this packet. So this is 7.2. Actually, looks a lot longer than it should be. When we do 7.2 tomorrow, I'll let you know. I also have the homework packet too, which is a side. So this packet's a little bit thicker than it should be. I made some copies I should have. All right, state the real part of the complex number and the imaginary part of the complex number. Now, the complex number, it's called complex because it has an identity crisis. Like, it doesn't know if it's real or imaginary. Kind of like that. You ever watch that Barbie movie? Yeah, I kind of watched it too. It was okay. I don't think it was that great, but anyway, it was kind of like this whole like thing between reality and fantasy, all that kind of like this. It's a dumb analogy, but the bottom line is it's a complex number kind of has this identity crisis, right? Like it doesn't know if it's real or imaginary, so it's both. So A plus B. Yeah, A is the real part, B is the imaginary part. Actually, all numbers are considered complex. Any number you can think of, like 2 is a complex number, just doesn't have the BI part. I is a complex number, even though it's just imaginary. So anything is considered complex. It's kind of like the overarching, like if you look at the hierarchy of numbers, it kind of like the big umbrella that covers all of the numbers. And when you write in standard form, you always write the real part first and the imaginary part second. So in this case, the real part is 0 because there's no A. The imaginary part is 8. Here, the real part's 3. The imaginary part's -5. Or, I mean, I should put the I next to, I suppose. So remember, your A here is 0. Your B here is 8. Your A here is 3. Your B here is -5. That's all. when you do operations of complex numbers, it's pure arithmetic. It's super, super simple. In fact, it's kind of like combining terms. Like example 5, that's 5 plus 6i, right? And it's 2 plus 7i. We're not out of the woods yet. What should I say afterwards? Is there a glare? Yes, it's fine. It's no glare. Yeah, it's fine. So yeah, if I combine it, what do I get? 7 plus 39. So tell me about example 6. What would example 6 be? Like, and you're subtracting, right? You're doing 2 plus 3i, but minus negative 6. So what's that to be, guys? What's 2 minus negative 6? 8. And what's 3i minus 7i? There you go. There, 4i. That's it. So, pretty simple stuff. Oh, it's kind of rude of me. Chris, do you want to introduce your visitors for everyone?
Oh,
yeah.
Hi, this is Lily. She's an exchange student. She's from France.
And how long will she be here?
She'll be for a month.
Month. Great. Okay. So, yeah, I should have done that earlier. Sorry. My apologies. I know you're interested to me, but I'm just full of class. So, all right. Anyway, multiplying complex numbers. It's just like multiplying variables, right? Like if you have negative root negative 25, root negative 4, it's kind of like saying 5i and 2i, right? Which is 10i squared or negative 10. Now, it's a little strange because you could technically multiply them, but I guess because of PEMDAS, you got to do the radical first for multiplication. So I think that's the reason why we don't do this. You know, you're tempted to do this, and there's a problem that allows you to do that for the vectors. But technically speaking, if you think of PEMDAS, you have to have exponent radical before you multiply. So that's why in this case we don't combine with this. We actually work on combine them separately and then multiply. So that's something to think about. So in this case here, let me make some space. That's 10i, and that's 9i. That's 90i squared. That's negative 90. For example 8, you want to FOIL. You guys remember FOIL process, right? You do first, outside, inside, last. Something you've done for many years now. So if I FOIL, what do I get? 4 root 2. What's the next term, guys? If I do the outsides. I root plus root 2 times root 3. Root 6, good. Plus 4i root 3. Plus I squared times 3. And it's not really too much I could do at this point. I know that's going to be 4 root 2 minus 3. And if you want, you could actually put it together like this. So it's fine, but I can't combine 4 root 2 and 3 because there's a radical there, but that's just negative 3. Root 6 and 4 root 3, those you can't combine that either. But what I did was I put the real numbers together. So I know what A is. A is 4 root 2 minus 3. I put the imaginary numbers together. So B is root 6 plus 4 root 3. So if I were being asked, hey, what's A, what's B? Then I can say, okay, A is 4 root 2 minus 3, B is root 6 plus 4 root 3. Technically, you're fine at this point, especially work with the I squared part, make negative 3, a little cleaner. But a little better writing like this and factor out the out. Just to easily see what the B part is. Because remember, standard form is A plus BI. Question on examples 7 and 8 about multiplying. All right. By the way, you can do this in the graphic calculator. The graphic calculator does this for you. Also, any juniors doing the SAT next month or ACT in April, some of you guys, they do complex numbers. They do a test on that. I'll show you can do in the calculator because you're allowed to use it. And actually, SAT is even better to have Desmos, which is even cooler. But anyhow, I'll show you how you could do this in the calculator. All right, next up, simplifying I to powers greater than 4. This is where it gets kind of funny a little bit. And actually, I've seen this question show up actually on the ACT. I do a lot of test prep on the side, so I see all these exams. When you look at I-27, why was it broken down this way? It was broken down this way because what you want to do is you want to do the exponent divided by 4. Because remember, the pattern goes in groups of 4. I to the 1, I squared, I3, I4, I, -1, -I1. And it repeats stuff. It's rinse and repeat. It just goes in this cycle, right? So what you want to do is if you're asked to evaluate I to the 27 or I to the 30 or some I to really some weird exponent, ask yourself, hey, what's the exponent divided by 4? And then get the remainder. You guys might remember like old school division. You guys remember this? How many times 4 going to 27, guys? 6 times. What's my remainder? So that's why I can write this I4 raised to the 6th power times I3. And I4 is just 1 anyway. So I3, if you go through the cycle, I, -1, -I. Okay, it's a third in the cycle. So it's -I. Let's look at I38. 30 is not divisible by 4, but it has a remainder of 2, right? So I1, I2, okay, it's going to be I like I2 is -1. I120 is 120 divisible by 4 cleanly? Yeah, right? So it's going to be the fourth in that sequence. It's going to be the fourth in that sequence. So it goes I, -1, -I1. That's why it's just 1. So looking over here now, I54 sounds like it's 3-way. I54, okay. Is 54 divisible by 4? Does it go into the limit? It worked out. I'm not sure. It doesn't, but it looks like it can. What's the remainder if I do the division? It'd be 2, right? It goes in 1. That's 4, 14, 3, 12. Yeah, the remainder is 2. So it's like I2. So it's just -1. Let's look at I123. How many times does that go in? 30 times. Ah, my 3 looks terrible. What's your remainder? 3. So it's like I3. What's I3? -I. Because remember, I1 was I2 was -1. We know this now. I3 is -I, and I4 is +1. So that's what you have to go through. That's all. But seriously, if you go to the calculator, I might as well show you the calculator now because we're going to do division in just a little bit. The division is kind of a pain. But again, if you see this on the ACT or SAT, just use your calculator. On my test, unfortunately, I won't let you because I want you to do the process. There's a process for dividing. I'll show you in just a sec. You might remember from Algebra 2. Yeah, but totally, if you hit second decimal point, that's where I is, guys. Hit second decimal point. And if you raise it to, like, say, the 123, here's what it's going to say. Now, it's kind of weird. Don't freak out. Why does it do that? I don't know. There's some weird algorithm that the calculator uses. But this is your A part, and that's your BI part. So it's -2.7 times 10 to -12 power, scientific notation. Now, hopefully from chemistry, I assume everyone's had some biochemistry in this class. Do you guys know what that means? -2.7 times 10 to -12. Is that a big or small number? Small. It's like a lot of decimal point. It's a decimal point, a lot of digits after the decimal. It's like zero, -0.000000, a bunch of zeros, and then 27. I don't know why the calculator does that. Why it just doesn't say -I? No idea, but just -I. So the calculator will do it for you. So that's kind of a nice thing. Okay, dividing. This is the last thing we'll do for today, and then you guys can get head start on homework. And we have a feeling so ambitious might start during your test or in class. We're dividing complex numbers. Now, the instructions will actually say this. The instructions on a test, and I'm surprised these notes don't have that. It should say to write in standard form. That's what the instructions really should be saying. Because what's standard form? A plus BI. Clearly, that's not A plus BI. Right? That's 2 complex numbers, one over the other, right? I need to make this look like this. Meaning I need to actually break this apart as -2 plus over this line. I need to identify what is A and B. So I get it sent to A plus B. Well, it's the trick here, and you might have seen this, it probably makes sense. You do the conjugate. So this is called the conjugate. It's just the opposite sign for the imaginary number. So this right here is called a conjugate. Okay, that's called the conjugate. And so why do you do that? Because when you FOIL it with the bottom, the i's go away. The i's will actually cancel out. Like if I were to work this out here, I would get 1 minus 2i plus 2i minus 4i squared. Well, what's negative 2i plus 2i? They cancel. What's I squared? Negative 1. So you have 1 plus 4, which is 5. There you go. So now this enables us to get into standard form. And actually, technically, you should write like this. Negative 2/5 plus 11/5 I. Where you can easily identify what is A and what is B. Likewise over here. We did top bottom, 5 minus 2 on both top and bottom. And when you do the both top and bottom the same thing, it's fair treatment, right? You're not changing the value of the number or the expression, but you're doing a cosmetic change. Really helpful comment. Okay. And by the way, the calculator will do it for you. Like if I were to type in like this right here in the calculator. So again, for those who are doing the ACT or ST, you're welcome. You don't have to do this by hand. Don't. And surprisingly, they still ask this. I've seen it like on last year's ACT exam. I'll show some of my files. They still do this, even though people can use a calculator. I don't know why, but people gratefully get the free points. So I'm just going to do this. If I see this, if I'm like, you guys taking SAT next month or ACT in April, I'm just using that. Cool. 2 plus 9. Move on. You have to answer in 5 seconds. Move on. So yeah, no need to do all this work. Yeah, the seniors probably wondering, how come I didn't know this? I don't know. You didn't know me back then. So anyway, but sadly in this class, I am going to make you show the work. That's just what we do. Now in this case, I'm going to multiply top and bottom by I, because I will at least get rid of the I in the bottom. So I get 6i plus 5i squared over 7i squared. 6i minus 5 over negative 7. 5/7 minus 6/7 I. That's all. Make sense? Okay. Example 12. I'm gonna have you guys do it and tell me what you get. I'll give you guys a minute or so to work it out. Multiply top and bottom by 4 minus 3i. I'm gonna let you guys do it. I'm gonna freeze my screen. Yeah, about 1 or 2 minutes. Here we go. So it's all foiling. That's what I get, guys. After I simplify, I get 1/5 minus 2/5 I. When you work out the top, make sure you foil it correctly. Chaos can happen. We're human. Makes sense. It's totally fine. But you should not get any I's on the bottom. You should not get any I's at all. So, okay. Any questions? And there's a lot more with complex numbers we could do. We're not going to do that. I mean, you can really get out on the deep end with this stuff, but we're not going to do that because it's not really relevant today. We're going to do this class for the future. So this is as far as we get with complex numbers. Kind of close the book on that, and then maybe we'll work on some equations that where the answer is complex. Fine, so be it. But that's really it. Okay, homework will be this. Homework is the back. Yeah, here's the homework. Pretty easy stuff. I do have the answer key for it too, which I'll post to School G. Just work this. That's all you guys doing today. Let me hand out the homework. And it's homework for the whole unit as well. Yes. The old one. Yeah, there's a new one. The old one's pretty stupid.
Yeah.
I call it Carl's to do.
I've always been.
Oh, yeah. Is your family Yankee fans or?
Yeah.
Yeah, they had some good years, but they've kind of yeah. Not struggle, they just can't get. They like the Buffalo Bills. They can't. Yeah. In some ways now. or like the Niners. Had their glory years. Stop.